So we're officially called LGEG, which has always been our acronym for London Gates Education Group. We have we have offices in Moscow and St. Petersburg and in Riga, which do A-level preparation, among other things. We now have a primary school in Belgrade. So I have been working there for more than 12 years now, and I have been preparing students for all kinds of exams, and the exams have been changing over these years. And I will show this. This is a part of the thing I will be showing today, that they changed the exams a bit. So let's start from some general thing. The problem is that I'm not a very I don't know very well about the general thing. I know how it works in Moscow or in St. Petersburg or in Riga. I know how the foreign thing works, but I did some surface research for today. So in general, this thing I know, they don't have obligatory exams at the level of what we would call school graduation at like EG. They do have obligatory GCSE, which is General Curriculum Standard of Education, I think. And this is 11 years of education. And then there are 2 more years, which are the senior classes, which are usually preparation for A-level, which could be actually international baccalaureate. I think that's what you've been discussing here previous times. So that's basically an alternative. And the interesting thing is that there is no like government agency which just creates the exams. There are different examination boards. There are at least 3 which I have here, like OCR, AQA, and Pearson-Edexcel. There are actually 2 more which are Welsh and not from Northern Ireland. But there, I think that they mostly work as the government, so like more standard, more customary for us. It's like they have 1 big agency for Wales and 1 big agency for Northern Ireland, and in England there are different ones. They are independent. There is of course a government agency which is responsible for, which is overseeing their work. But basically, a school can choose if it's gonna work with one exam board or another. And the interesting thing is that the programs are going to be different. So they will be roughly similar, but the actual differences can be quite significant. And we'll see about this. So OCR is Oxford, Cambridge, and Royal Science Academy, and AQA is something else, and Pearson is the one which we're more familiar with, which is the kind of private, which is a editor's house where they publish a lot of books, student books. I think everyone has probably seen them. So they used to have a system with a lot of modules, which means when you take an A-level exam, when a student takes an A-level exam, they actually have several exams to write, several papers, and they're up to 6, I guess. It has been 6 in mathematics. It's been a bit fewer in different subjects. So the idea is that you need to take each exam, and then the grade is the cumulative grade for all of them. And the exams were taken gradually in the course of these 2 years. So you could take an exam in January of your first year, then June of your first year, and January 2nd, and then June 2nd. And then this way you can, if you fail something, you can retake it later. And apparently, according to Wikipedia, that's what they were fighting during the reform of the 2017, that they had this reseat culture, that people would retake exams and retake until they get good grades, which in my opinion is perfect and definitely lowers the pressure on the student, because they're 17, they have lots going on in their life, and having one single day define their future, at least how they see it, as it works in EEG, for example. This sounds very bad, and I like very much the idea that they can leverage their responsibility over days, and then if they're in a bad state, they can just retake it half a year later. But after 2017, they changed this. There are still several exams, so but all of the exams need to be taken together in one session, which means it's like June of the second year of their A-level program. They write 3 exams in 3 different days, probably, but that will be 3 exams in mathematics or something. That depends on the examination board, but roughly 3 papers to write. And if they need to retake it, they need to retake all 3 and next year. So this is basically close to what we have. That's huge pressure. You don't have it like an opportunity to fail. You have no right to fail. But luckily, there is an international A-level, which is something which works abroad usually. As far as I understand, most of the people who take A-levels internationally live in India and Pakistan, usually, because that's like places where they speak English a lot, and they have huge ties with Great Britain, and they have a lot of people who write the exams there. But the exams are available everywhere. For example, they used to be available in Russia, no longer, but now our students write them usually they write them in Yerevan or in Astana or in Istanbul, but basically you can find centers which offer international A-levels almost anywhere. And for international A-level, there are also several examination boards, though now they are different. And the one which was OCR, which is like Oxford, Cambridge together, they don't offer international exams, but Oxford pairs with AQA to offer Oxford AQA exams, and Cambridge has its own Cambridge International, which is, I guess, a big part of their business and income as a university. And Pearson-Edexcel, the one which offers both internal and external, and this is the one which we work with, but that's going to be later. And the international exams actually survived the reform. They didn't change the modular system. There are still different models to take. Our students still have the chance to write several exams, different days. It's very convenient. I think, from what I understand it is possible to write international exams inside the UK, but that's not usually happens. But if somebody needs this, they can probably find a center within the UK which would offer this. Wait, something is missing.
And Sergey, may I, if it is possible, maybe you can make the shape of your screen, the area that you share, a little bit wider, because it's perfect. It's perfect now.
Is it better?
Yeah, much better, because I have when we zoom to the actual shared area, we have a line of cameras at the bottom, and so on the top it's better to have a wide line. Mm-hmm. Thank you.
No problem. Wait, I'll try to. Okay, so this one is about what happens in mathematics. And this, from now, I will be generally talking about international exams because that's what I know better. I looked a bit at the internal, things which they write in the UK. I'll say something about it a bit. But so this is the international. This is what the international exams look like. One of the features of A-level in mathematics is that they have pure mathematics and they have applied mathematics units. And applied mathematics include mechanics, statistics, and decision mathematics, whatever that is. So they, to get a degree, to get a certificate in the A-level, the student needs to usually take both pure and applied. There are certificates which are called pure math, and then it would be not like a level in mathematics, it would be a level in pure mathematics. And these students don't need to take any applied units, but that's not very standard. So the usual thing is that people write pure and applied. For example, one of the crazy things that they made in the reform inside the UK is that out of the 3 papers they write, they have 2 big pure mathematics papers now, at least in Edexcel exam board, and one which is called Mechanics and Statistics. And from my experience, our students suffer both with mechanics and statistics, and joining 2 completely different things in one single exam sounds like such a crazy idea. I don't know. That's like this is really very, very weird, but that's what students in the UK experience now. So they have one exam which is called Mechanics and Statistics, and they need to prepare to 2 completely unconnected things. On the other hand, one of the properties of the British exams in general is that there are a lot of topics which are not obviously connected with each other. It's you can have, I don't know, we will look at the topics later, but basically chapters of the textbook can be very, very unrelated also. So even if it's one same unit. Anyway, so this is a slight overview of what is offered. I tried, while preparing, I tried to look at what they have. So they have very weird systems, both AQA and Cambridge. But I guess that's because I'm accustomed to Pearson, and probably they think that our system, the Pearson system, is complicated and their one is obvious. The thing is, everyone has a pure exam, but for example, Oxford has an exam which is called Pure and Statistics and Mechanics, which is obligatory for students who are doing A-level. And Cambridge also has an exam which is called Statistics and Mechanics. And then they usually need to choose one extra unit if they do mathematics. So they in Oxford and Cambridge they have they have something which is both a bit of both statistics and mechanics, and then they choose if they want to do statistics or mechanics at a bit higher level. And another thing, okay, that I didn't mention it, but there is in terms of subjects, you can take a level in, I don't know, physics, chemistry, Arabic studies, whatever, and there is mathematics, and there is further mathematics, which is a totally different subject. And you get a second, if you take both of them, you get a different degree, like different certificate, different grade, and when you apply to a university, you can say, I have A star in mathematics, and I have B in further mathematics, and B in physics. And that's your 3 grades for the university. The universities usually require 3 exams. So the thing is that both for Cambridge and Oxford, the international exams, further mathematics and normal mathematics units are totally different units. They are not mixed up. So they have still the same stuff. It's still mechanics and statistics, but it's called further mechanics, further statistics. So they have different units. In Edexcel, the one we work with, they have a bunch of units which a student can choose if they go into mathematics or if they go into further mathematics. They're the same units. So, for example, our students who take both subjects, math and further math, they would have, in the end, a lot of exams, like 12 exams written, and the applied units can actually be a little bit mixed up. In fact, it's not even the student who decides, it's Edexcel who decides. They have an algorithm which is supposed to maximize the total grade, which is a bit interesting in terms of the grade, because they have strict rules, and they would prioritize, I think that they would prioritize AC over BB, for example. So if you could remix your grades to get a different note, you would normally not have a chance. And they would say, okay, we have rules. If you got an average A if we can't get you an A, we will mix up all your good exams into mathematics, you will get an A, and the rest you will get live for further mathematics. And if you get C, well, you're unlucky. And if you had an offer from the university which was a triple B, which means B in every subject, that would probably be a cause for concern. But I think that universities are slightly flexible on this, that you could explain to them that this AC actually is the same as BV, but that would require special communication with them. So that's a kind of an overview. From what I understand, recently there is no decision math units in either Oxford or Cambridge international exams, but Edexcel still has decision one, and that's one of the best exams. It's completely absurd, but it's very easy. So I will tell about it as well. So that's more or less, that's an overview of what is happening with A-level exams in general, very roughly, with A-level in mathematics, with international and non-international. And I'm ready to go to more specifically into what we do, into Edexcel International Mathematics. But maybe anyone wants to say something so far about the general thing. Ask, I don't know.
Well, I want to ask a question. So, like there are two different exams, math and further math. Yeah. So, can a student take further math without math?
That's a good question, actually. I think that yes. I would be surprised if anyone would ever do this, because usually they take exams for universities. But imagining somebody who is doing it for fun, no problem. There doesn't seem to be any limitation. Why not? But yeah, that would be. We have never had this, but we have a policy that says that mathematics is an obligatory course in our centers, just for our internal reasons, that we think it's a bit easier to manage if everyone has at least one subject in common. But yeah, that's a cool plan.
Yeah, but you said that people who go to universities won't do that because like mathematics is easier than further mathematics, yeah, and they could have better marks, yeah, in general, yeah.
I think for both because of this, and because if any because universities usually have not just say you need a triple B, but they actually say in which subjects at least the first two would normally be required. And usually if it's a more or less technical something, they would say that they need maths. That's like normal for them. So I think, but also of course because it's easier, yes.
Yeah, but and so well, maybe it's not a question about mathematics specifically, but just well, you said that somebody could take like math, further math, and what and physics, yeah, for example.
Yeah, that's a classical case for going into some mathematical university or physics university.
And so yeah, like and in your centers, like people usually attend schools, yeah, and they during evening they attend your center. Yes, am I right?
Yeah. We have they usually come to us in the evening for that. I will talk about this a little bit. Yes, that it's not their primary education.
Yeah, but yeah, so but for people who are in UK, yeah, for students who are in UK, do they really have like are there really a lot of people who just like for 2 last years at school they just study maths and physics and that's it?
I think that they study everything. They just don't take them as exams, and they don't prepare for exams. So that's again, what I read today was that not very deeply in Wikipedia, obviously. So Wikipedia says that people usually start by taking 4 exam courses
Mm-hmm.
and then drop one in the second year because the university usually needs 3. But I'm pretty sure that they still, when they go to school, they have all the subjects. They just don't. Maybe they, for example, have different levels in school, and then the school decides if you go to an exam group or non-exam group. Depends. I know in Cyprus, private schools which tend to follow British curriculum, they would generally create internal exams which would be very similar to A levels, and then the students are just allowed to say, okay, I want to take this exam as official A level, but they are already prepared for more or less internal exams in multiple subjects. But
Mm-hmm.
that's what it looks like.
And Sergey, if you are here, yeah, can you show your experience in Riga? Was it the evening school, or it was a main a main education for those in A levels group? And did they have other subjects than ones they prepare to take A levels in?
No, that was not an evening school. That was a full international school, which offered A levels, A levels curriculum as well as IB, and students had to choose what they join.
Yeah.
And A levels in the school where I taught, they had to choose 4 subjects. It's very similar to what Sergey mentioned. They had to choose 4 subjects, but they only required to take 3 exams. And these 3 exams technically may be just STEM subjects or just humanitarian or a mixture. So you can have students who take, for example, math, physics, chemistry, or history, psychology, whatever, economics. Or you can have a mixture, like math, physics, and history. And the 4th course serves as I would say, your safety options. So if, for example, you start doing 4 courses and you realize that one of them is too hard or not so interesting as you thought, you may actually drop it for the second year, or you may still continue taking it, but you don't have to take an exam in it. And we did not have any internal exams for the course that you're not taking as your official A-level exam. And also, one other thing that Sergey mentioned at the beginning, but just to clarify a little bit, there used to be 2, I would say, sub-levels, AS and A. So what was allowed, that AS is something, it's part of the entire curriculum that you can take in your first year of the program, and that would count towards your overall diploma. So in the second year of the program, you can only take the second part of the content. Starting, I think 2021, if I'm not wrong. I don't want to lie about the date, but it's a very recent change. You can take AS in the first year, and that's what we did as a kind of practice exam, but it's no longer counted towards your overall exam. So you still have to take the full course at the end of your second year. And by the way, it's also interesting to note that that's just a typical thing in education. That's right now in Great Britain, England itself actually is on the way to eliminate the A level at all, whereas Wales is actually keeping it so far, but England is completely combining it with what they call T level, which is like more general education, because A stands for advanced, and they're kind of giving up this idea. That's as far as I know, last year's 2023. I mean, news development that happens in England.
Yeah.
Okay, just
Yeah.
yeah. I'm
Mhm.
sorry for the interruption, but can I add something as a college counselor with respect of this AS or A2 levels, just for everybody to make sure that we are on the same page?
Yeah.
Well,
Mm-hmm.
Sergey mentioned, correct. There are 2 actually tracks in the international A level. First one, it's the modular, and the second one is the linear. All of the modular things, such as, like, let's say if we are dealing with the CIE, Cambridge International Examination Group, they call it as a staged, not the modular, but as a staged. When we are dealing with the modular sections, at this like in 2024, you can actually count some of the modules and get this AS score to use as a part, like let's say 50% of your final grade for any like maybe specific courses in different universities using this UCAS grades and etc. But there are still AS grades because, for example, when you are dealing with the Pearson-Edexcel, you can actually cache in some of the modules in order to get this AS score. And if you don't mind, maybe in the end of this presentation, I'm going to show you how it looks like. But if you don't want just to count them as the AS score, you can add up all of the 6 modules in order to get the full A-level grade. This is how it works. And it works, to be honest, with the Cambridge, with the Pearson-Edexcel, and with every like other exam boards that are still dealing with this modular section. But with respect to the linear one, when all of the exams are taken in the end of the second year, of course, there is no such thing as an AS stage. This is just the small addition.
Thank you
Yeah,
very much.
actually, I've thanks. That's cool. I've seen today that they have a separate AS specification in Cambridge. Like when you only take pure math one and pure math two, and you get an AS in math, which doesn't count for anything, at least on international level, as I understood. And it's funny because if you take the full exam, you don't take pure math two, but you take pure math three. That's kind of surprising a bit for like the way that works. So
It's just this is how CIE, to be honest, calling the papers. The
yeah, yeah,
content,
yeah.
the content itself. It's actually the same as the, let's say, if you're dealing with the mathematics from 2017 when it was all about like C1, C2, C3, C4, all of these pure math papers are all about core, to be honest. And yes, CIE are calling them as like PM3. Like it's just
Mhm.
special things for this Cambridge board. Nothing in particular with respect to the content.
Okay.
Yeah, and when I asked Sergey, I just wanted to clarify that yeah, it's possible, and as I think it is usual that yeah, people who take A levels as their like main education, not even in one year, but as their main, they really study very few subjects, like 4, and no other subjects are studied. Yeah, that's cool.
Yes, that's correct, and that's actually one of the things that because we follow the Cambridge model, and we actually met with the Cambridge representative one one day, and actually Cambridge is now considering changing this model more towards like IB structure, where you have more than 3 exams to take, because they realize that the one of the reasons why they kind of, not drastically but significantly, losing popularity, and they're losing it to IB, because when students have to only choose 3 subjects for their last 2 years of high school, those students who are well determined about what they want to do in the future, it's a good thing. But for those students who are still undetermined, it may be a problem, because if they go into the focus in 3 subjects and then suddenly they decide to slightly change, it's kind of a little bit hard for them to catch up. So I know that Cambridge right now is also considering to revamping their program a little bit into. I don't know if it's going to happen or not, and when, but that's what they're considering. But yes, in school, the students, and that's why in our school, where both programs were initially offered, IB and AP, and sorry, A levels, it was unofficially considered, even though it's not true, unofficially considered that A levels is for students who, like, how to say, not weaker, but who do not want to take a burden of many subjects and want to just do fewer subjects. But the trap was that those fewer subjects were so much more deep and elaborated that sometimes it's easier to take 6 subjects in IB than 3 subjects in A levels.
And by the way, so if people, for example, are in UK or in like Pakistan or India, yeah, where I think that still A level school are much more popular. But the like or like so some situation that a student is in A level system and but wants to have more subjects. Can he take like 6 A levels? At least to study, not actual exams, but to study 6 A level subjects, like in IB.
As far as I know, it depends on the school, what the school allows. But from my experience, to take 6 subjects on A level, not many students would survive
Okay.
because they're really deep. They're really like focused. Like if you even talk about math, look at this. It's on the screen right now. The only fact that it has mechanics makes math course in A levels much more elaborated because it's something that almost no other math courses do. And I can tell you from the point of view of teaching, a lot of schools face a challenge because not all math teachers can actually teach the mechanics section of the math course.
Yeah.
So sometimes they actually combine and they ask physics teachers to teach the the mechanics section of the A levels math. That creates quite a challenge, I would say.
I see.
That's why not many schools take on them the burden of offering the full scope A levels because a lot of interesting things.
And in your school, Sergey,
And
so students like usually A level students took four subjects, yes. And well,
yeah.
sorry that I dig deep into it, but I just if we touch that,
Oh,
how were the hours distributed throughout the week? Yeah, through how many hours weekly of mathematics?
That's a good question. I think they had let me recall right now how the schedule looked like. I think they had 3 double lessons, which was like pairs of lessons, 3 doubles lessons per week, and they also had the fourth pair, I think, once in 2 weeks, something like that.
I see.
Yeah, and I can tell you the scheduling for this was crazy because students, you can imagine you have few students who take all different combinations of 3 or 4 subjects. That was the reason, to be honest, why the school where I worked later gave up in A levels and only stayed with IB because they could not figure out the schedule for both tracks. Because in A levels, basically, you end up with classes of 2 or 3 students in some subjects, which is a great educational environment, but it's completely, from economics point of view, it's completely not beneficial for the schools,
Yeah.
especially for international schools. Especially if they're private international schools, which, for example, in Riga, where I worked, most of international schools are private schools, and you have a lot of competition. So, this like in Riga, which is it's a small town, but it's in terms of cities, it's a relatively small city. It's 600,000 people only. And Riga has 4 official international schools. Plus, it has a couple of state schools that offer international programs, mostly IB, but I think one offers A levels as well, in addition to their state curriculum. This is a complete killer. Students actually take their regular courses and take their regular Latvian exams, plus the full international program. Plus, they have Sergey representing London Gates, who also offers international curriculum. So there's a lot of options, which is great. It's a lot of competition.
Yeah, with this amount of schools, no wonder that there are very few people who want to go to London Gates to study A levels now in Riga.
Exactly, yes, because they're like, I'm telling you, four official international schools, three of them are located in the same small village near Riga, within walking distance from each other. That's like a unique situation for the entire world, because much larger cities than Riga in the world have like one or two at the most international schools. And Riga has like, four, plus London Gates, plus the state schools that offer the international curriculum.
Cool.
I know that a lot of students go to London Gates for English in Riga. That's a good part.
Yeah.
It's not about math, but that's a good part. London Gates is very popular in terms of English, and I know a lot of teachers actually want to work at London Gates and teach English.
Nobody wants to teach math at London Gates in Riga. That's a
Math?
problem for me.
No. I know. I was part of the interview at some point as well. Yeah, I know.
Okay, let's go into the contents, into the exams themselves a bit. So now about what we have. We have 3 exam sessions per year. The winter session, the summer session, and the October session. October session is not complete, so it's not every unit exam can be taken in October, but that's actually turned out to be an extremely good thing when they introduced the October session, because first of all, students who failed in their first year, they can retake something not together with their second year exams, and second, we used it for one exam as like standard program exam, because it turned out that it helps to focus the students when they come to you in your second year on. They already understand more or less how it works, and then you can say, okay, guys, have an exam on the 31st of October. You have 2 months. We don't have any time for feeling like we're still in summer. We just work, and that turned out as a very cool idea. The exam schedule is pretty flexible. They can take whichever exam whenever they want. Of course, it's not like we know that we have a course and we prepare for this exam in this term, like first year's second term spring session, they have this exams. But in general, the students can take anything whenever they want, and then they can retake whenever they want. All the exams in mathematics, that's not about everything, that's mathematics, they are all last 90 minutes and have 75 points. Each exam has the same final value. All the 75 points stuff is then transformed into the thing which is called UMS, like universal score, and it's out of 100, and that's a different story. Actually, that's an interesting thing, that they transform the exams using more or less quantile system. So they try to make the grade of 73 each year to be valid more or less the same. So to be valued at the same level. So they try to make it that the same percentage of people scored above 73 or above 92 or something, which is pretty cool. I think that they tried doing this in EGA at some point, but they gave up immediately and just fixed the scale. Actually different, this is the thing that everything is the same in math is pretty convenient, because, for example, physics also has 6 units, but some of them have 80 marks for the exam, some of them have 60, and then some of the exams last for 1 hour 45 minutes and some for 1 hour 20, and then it gets to be a mess in terms of everything. And for math, it's simple. You get like just everything is the same every time. So here is a little bit of an overview of what it used to be. The before 2014, I think, was before international even was introduced, at least at Pearson. We worked before 2014. I didn't work too many years before, but still I was already working, and we were making the choice of whether we want to continue offering general thing or we switch to international, and that was a very good thing that we switched to international. And one of the actual main advantages was that there would be a we would keep the winter session, and that was our main argument because we want the students to be able to distribute their exams evenly. The units, you can see that before 2014 there were like a lot of units. There were 5 units of mechanics, 5 units of statistics. I don't know what used to happen in like mechanics 5. I have no idea. Even with mechanics 3, I am very like not very familiar. I have some ideas, but yeah. So then the funny thing was that the reform changed. The C1 and C2 exams were joined into C1-2, and the C3 and C4 into C3-4. That was very funny because, well, that was some experience, and that was the moment when the exams were not 90 minutes because they were double unit exams, and they lasted 2 hours and a half, and offered 125 marks. That was quite a challenge for our students because you need to concentrate for 2 hours and a half on the same thing. Though, well, EEG is 4 hours, so and then they split them back in 2018 into P1, P2, P3, and P4, which were actually not similar to C1, C2, and C3. C4, they mixed up the topics a little bit. So the union thing went very smoothly. They basically took C1 and C2 and merged them into C1-2. It was the same program. We didn't even have any different textbooks. We just had textbook C1, textbook C2, cover both. That's your C1-2. And then when the new things came, so the C meant core math and the P means pure math, what a change in naming. They actually reshuffled the topics a little bit and then added something new, which was for us not very convenient because it increased the number of hours we need to cover everything. On the other hand, the other units didn't change almost at all. The only change was in decision math, which is still so far unknown because it's I guess that might sound like a total riddle what it is. That was me before I started teaching it. What I wanted, why we chose Edexcel in the beginning, I think that flexibility was one of the reasons. Actually, the choice was made before I started working at London Gates, which was like they made a choice and then they started hiring people. So the rumor, the internal rumor inside the center is that they chose Pearson because it's the easiest. I don't know how they evaluated this. I looked at several others. I would rather agree, but it's hard for me because I'm very, very accustomed to Pearson and I know everything there like by heart and every single small detail. But it seems to me from like after a surface review that actually the other exams have more material, that Cambridge has more material, that AQA has more material. So, and obviously for us working inside another school program, the closer it is to the original Russian program, the better. And the further it is, the further it goes away, the worse. So one thing which I would like to say here is about, I don't know how familiar you are with the British education. We're developing a primary school at London Gates, both in Moscow and in Belgrade. And I've been looking a little bit at primary school programs, and they leave the same impression as the A-level program, that compared to what is done in Russia, they actually try to go. So they try to cover multiple things. So they develop extensively rather than intensively. They say, okay, you are in second grade, but we will study fractions a little bit because why not? And then third year you kind of go the same things deeper, and then you go again a little bit wider. And that's close to what is happening in A levels. They go pretty wide. They often don't offer too much of a challenge in terms of thinking. The exams are the tasks are pretty algorithmic. You do the same stuff every time, which is very different from what you have in like EGE, for example. In the second part, you often need to know very many methods, and they will be very different. And but they go into very different places. So they have, for example, differential equations in normal pure math. Even students who don't take further math, they would study some differential equations, which is pretty fancy. But it seems like it's a British thing to go wider, at least from what I have seen at different levels. So what we have in what our students take, they have currently we have 4 pure mathematics units. They are more or less normal mathematics. I will show you the contents a little bit later. And in further mathematics, they take the further pure one. Then they choose between further pure 2 or further pure 3. And then the rest is filled by application units. So as I said, they need 6 units altogether to get a certificate. So in our center, we do students who study pure math do mechanics 1 and in the first year and mechanics 2 in the second. And so statistics goes into further math, and they take statistics 1, statistics 2, statistics 3, and decision math in addition to FP1 and FP2. But actually, at some points, we switched statistics 3 to further pure 3, and our students took 3 further pure math exams. It depends, basically, if you have a very strong group which are interested in mathematics, in pure stuff, and they like, I don't know, taking integrals, you go more into this, and they say, why would we care about running more hypothesis testing? That's pretty boring. You can do the interesting stuff. I liked further pure 3 very much. Before I started teaching statistics 3, I realized that it's just much easier for the students. If the group level is lower, it's much better to go into this. But actually, as I said, first of all, the thing we do doesn't affect how Edexcel later would attribute these exams, and they may actually take S1 and S2 into math, and then M1, M2 into further math. That depends on the total grading, because they need to maximize the total marks for the exams. And but for example, in normal mathematics, you are not allowed to have Unit 2 without Unit 1. So if you take, if you took all the possible exams, then you cannot count mechanics 2 and statistics 2 into normal math. You have to do either M1 as M1, M1 M2, or S1 S2, or M1 S1, or D1, actually. D1 is the decision math. So this is the outline of what the students face. They write 6 exams in mathematics and 6 exams in further mathematics, which are distributed over 2 years. So it's like, even without October session, that would basically mean 3 exams per year in each subject, which is not a lot, but not horribly a lot. And the exams are short, 90 minutes. But of course, the course is still pretty intense. Some general facts about Edexcel exams, but all more or less general exams, I think. So they have a calculator always. I saw that you were discussing the usage of calculators for, I think it was for AP, right? You discussed it for AP?
Yes, yes. So we've seen, yes. So,
was it more about this?
Yeah.
Texas Instruments stuff.
Yeah.
Okay, so in here, that's not that important. You need to be proficient with your calculator, because you don't have time to waste on it. And that's another part. The timing is actually pretty tight, but the functions which you use in the calculator, they are very few. You need to know how to make powers. You need to know cosine or arc cosine. Like, you need to work really with trigonometry. More or less, that's like, you need to know the logarithm, exponent, but only the basic functions. So you don't do programming or anything.
Or graphing.
Which actually,
graphing is not.
Yeah, you actually are allowed to have a graphic calculator, but you're not allowed to use it too much. That's the interesting thing. But you are in some cases, if you have a graphic calculator, you can actually sketch a graph, and then you, if the task says sketch a graph, you can just redraw it from the calculator, which is a bit weird. But I think that they are allowed. They have a strict rule about what is allowed and what is not allowed for a calculator. One thing which it is not allowed to do is to do algebraic integration or differentiation. So it is not allowed to tell you what is the derivative of x squared. It is allowed, though, to tell you what is the integral of a function, like the definite integral, because it doesn't help. If you get just the definite value of the definite integral, whatever, because you won't score the marks without getting the antiderivative.
Mm-hmm.
So there is a funny rule that students are allowed to have a dictionary if they're writing if English is not their native language. But again, it's like using a paper dictionary takes time, and you don't have time for this in the exam. So normally you just ignore if there is a word you don't understand. At least in mathematics, you definitely just try to ignore it. Most probably you don't need it. And of course, there is the formula booklet, which is pretty cool. That some of the formula you don't need to learn. You can look them in the exam; they are there. For example, a lot of derivatives and antiderivatives are given. Like, you don't need to know what is the derivative of tangent; it's written there. You just open the page and see what is the derivative. And the best thing, which for me has always been completely amazing, is that all past exam papers are available. You can just go to the website of the exam commission, of the exam board, download the papers and just solve them. And because the exams are actually very, very similar throughout the years, even despite the reforms, they pretty much, many of them survived. And even when the unit is different, like P1 never existed before, but you can take the C1 exam from 2008 and many tasks will look similar. So and this is amazing. This is something which Russian EGEG lacks a lot, I think. Why not publish the official papers? What's the problem? I think that this is also the problem with AP, actually. From my experience, AP doesn't publish their previous year papers. I hope I'm not wrong. And this always...
Just sorry to interrupt. This is not exactly true. AP publishes their open-end questions. They are available right after the exam. What they don't share multiple choice.
Okay. They share
they share multiple choice. Yeah, they share multiple choice once in like maybe 5 or 10 years, the actual exams, but they don't share multiple choice, and that has some rationale because multiple choice, they're very like, in AP system, multiple choice is very like fast paced. They're like really basic, and if you have all the real exams, you can very quickly basically get drilled, and because there's not a huge variety within multiple choice. I would put it that way. Okay, but open-end questions are all available.
Okay, so that's not as bad as I thought. Fine, that's good.
Yes.
Because it's surprising how much it helps. Like solving past papers gives you such a boost in the actual exams. That's just incredible. And obviously the final results of the students, well, they are defined, of course, by how their ability, but in addition to ability, even the most mathematically able students would fail if they never solved any single past paper, and vice versa. Even if the student is not that mathematically talented, if they solved every single past paper available, they most probably will eventually get a very good grade, because the exams are the tasks are pretty standard. There are very classical algorithms. You just follow what you want to do. And some more facts about how it works, that usually you have each topic has one task. It can be sometimes, like in mechanics, they can mix dynamics and kinematics in one task, and then first part and second part or something. But very often it's just You have a topic, you know that there will be a task on this topic, it will be in the exam, it will be one big task or one small task, or sometimes you will have one big and one small on this topic. You can, looking at the papers, you can very easily understand what to weight. And in particular, if a student doesn't actually care to get an A star, they might decide, I don't care about this topic, I will just drop it, not study it at all. And well, you won't get an A star, but probably getting an A is not a problem, even like this, if you solve everything else. On the other hand, for us, it is, of course, there is this kind of a minus because we work in a evening center style, and so the students come to us once a week, and it's one topic, one more or less one topic per week. So if a student is ill and doesn't come, they basically have -1 task in the exam, and they have to recover it somehow. But that's a different story. And one specific thing which I like very much is that you have a mistake would usually mean, okay, you made a mistake, you lose a mark out of 7 or 2 marks out of 7. You don't lose the full task, even if the mistake was a pretty in the beginning. If it's, well, of course, if I had a case when a student integrated instead of differentiating, and that kind of messed up everything completely in the very first line of a very expensive task. That was a pity, but it was a very smart student. It was like a real pity. But normally, even a mistake in the beginning would not lose you all the marks, and you can still score quite something. Yeah, so the marks give you the idea of timing, but that's, we usually tell our students, you have 75 marks, you have 90 minutes. That means 1 mark per minute. The rest is for you to revise, to look again, to check. Normally doesn't work. Nobody ever gets to solve 1 mark per minute. I don't know why. But in fact, of course, there are tasks where you have a 5-mark task and you actually do it in 2 minutes, even if you are not the smartest person, you are just somehow prepared. And sometimes you have a 3-mark question and you need to actually spend 5 or 6 minutes because it's longer, but that happens. But roughly it's all very even. And the teaching for the exam thing I put here because that's what we do, unfortunately. So because we don't have too much time, we usually focus on actually teaching our students to write this particular exam. And we don't have much time to discuss the mathematics behind it, the thing which I kind of don't like too much. I prefer when my students know where did this come from? What the hell am I talking about? Why I say that there is a formula? How does it work? Where it came from? They are usually not as interested as I am, but still, I think that that's a kind of a honesty, mathematical honesty to tell them this. And that's, for that, we don't have too much time. In further math, we have more time usually because the students are further math, they choose it, so they are more prepared, they have more time. We can concentrate more time on this rather than on explaining simple stuff. But in normal math, that's often just the basics. Okay, at this stage, it's time to go to contents, but I know we've spent an hour. Do we move on? What do you think?
Well, it was interesting, so we discussed a lot. So now, what do we have ahead of us?
So the thing is, we have basically we have contents of whatever is happening there in mathematics. I have this is the you can see the content, rough contents of all the pure mathematics, and then I have just for every unit everything, like all starting from pure 1 until statistics, mechanics, everything. I have just our program kind of like list of topics, more or less. We could look at it, or we can leave it. The thing is that it might be interesting to compare this with other programs, but then I don't know, maybe we need to make a different talk just about the topics and the contents. Maybe we can look specifically at something and look at topics with examples of tasks. Would be this. I don't know, but I'm ready for anything.
Well, maybe we can talk a little bit. By the way, so we had a brief conversation about calculators, and when we talked about calculators with Sergey, calculators for AP, well, we discussed that usually it's TI, yeah, and teachers have, in schools decide what calculator do they use, and every student like it's compulsory to have one of them. Yeah, for example, TI 84 or TI 83. And do you have any restrictions or suggestions about calculators?
We bought for us in Moscow. We bought some simple Casio calculators for 500 rubles or something that had all the capacity they needed. They are not super smart, but they can do trigonometry, they can do exponents, so they actually can do more than we need still. And we recommend to use them mainly because when you come to the center, you can use it in the lessons. But if the student has different one, we don't care. It's not really that important for A levels. It's you really you need the basic stuff. You don't need. I mean, you can do e⁵ in any calculator, or you can do cosine of 73 degrees in any calculator. You don't need special training. So the main thing I usually tell my students is that they come to the lesson, that in the lessons they use the same calculator they will be using in the exam, because that's their habit and that's their time in the end. But yeah, nothing else.
Okay.
So,
I'm sorry.
Yeah.
I just wanted to say that I think the major difference is that, as far as I know, A levels does not have any kind of prescribed models of calculators that are approved for the exam. Yeah, whereas AP does. That's why we have special models that we recommend, because AP has a list of calculators that are officially allowed on the exam, and it's based on the calculator capabilities, because AP depends on calculators more heavily. They have, as we discussed, sections that actually require the use of calculators. And that's why they want to make sure that the calculators they approve have the functions that are needed, but don't have the functions that may help to solve non-calculator problems. So that's why they make this kind of crazy list of approved calculators. And speaking of Casio, these are two major competing companies, TI and Casio, who produce educational calculators. But the interesting thing is that TI is mostly geared towards education, whereas Casio historically is more geared towards engineering. And that's why they have several interesting differences, which I had a couple of instances where they got students in trouble. Like, for example, Casio calculators, when you talk about measuring angles, unlike TI that has standard 2 modes, degrees and radians, Casio has 3 modes.
Yeah.
Casio has that called a gradient mode that most of the people don't even know about. And we had a student who literally, like, religiously argued with us that he got a value for sine of a certain angle on his calculator, which was completely wrong and did not fit any of the formats. And then we figured out that he was accidentally working in gradient mode. And I wonder who here knows what gradient mode is. It was an attempt at some point to turn degrees into a metric system and do them also base 10. So that's why they introduced a new unit for angles, which was 1/100th of 90 degrees. And that was called gradient. And Casio has that mode, which I don't know who even uses now. Also, there are famous arguments on internet all the time about the order of operations problems. Like, if you have numbers and there's a number next to parentheses without the multiplication sign, what comes first? I'm sure you all saw those arguments.
Oh, yes.
And And I'll be honest with you, I must confess, until quite recently, I was like flipping out at these arguments, saying, "Come on, people, there's an order of operations, nothing to argue about. You just need to know your order of operations. It goes left to right, division, multiplication. So, of course, you do division first and multiplication. That's it. That's how all calculators give you the answer if you try." I was completely shocked to see that there was a huge research done by one of the young teachers in the States, and she actually did the research that it's not true. And Casio calculator, if you put the same exact problem into it, gives you a different answer because they use instead of classical PEMDAS in English, like parentheses, exponents, multiplication, division, addition, subtraction, they use PEMJDAS, which is adding so-called juxtaposition item into the order of operations, saying that when the number is right next to parentheses without the sign, it's multiplication, but this multiplication has priority over the division. And amazingly enough, in most of academia papers in mathematics, not educational textbooks, no textbook has that, but academia papers in mathematical research uses this PEMJDAS all the time.
Yeah, that
And
was
that's
my
why
intuition.
Casio,
I was sure all
yes,
mathematicians would do this. That just sounds, but if you think of it, I mean, if you drop the brackets, imagine that you have 3 divided by 2x. It's the same. You would normally understand it not as 1.5x. You would understand it as 3 over 2x. So that's that.
that's questionable. At
Yeah, yeah,
school
of
you would
course.
not. Yeah, at school
Yeah,
you would
at
not.
school,
Anyway,
yes.
not to, sorry, I don't mean to divert the discussion, but it's just that you mentioned calculators, and these are the things that are different between AP and A levels. That they're more like
Yeah, that's
clear. AP
true.
is more clear in terms of models it can use, and that's why TI usually is more used at schools than Casio, because Casio has this few interesting things that are not very common for educational institutions.
Yeah, I had a very brilliant student who eventually got into Imperial and got her and is now getting her PhD in Germany or something. And she in the first exam she was like, but why? I took the calculator and it told me that the arctangent of 1 is 50. And I was like, what the hell? And that was exactly this grad thing. And
Yep.
it wasn't the exam. And she was like crying that she will now fail everything. And how could it be?
No, our student was very persistent, and we had actually 5 teachers panel looking at that. And when we figured that out, we had to give him point back, just making the calculator error versus content error.
Oh,
So
yeah.
he won. He won, which is to his credit. We were very happy we were able to honor his claim.
Yeah, but anyway, the A11, of course, doesn't require the level of sophistication of the TI calculators. Usually, we use some very, very
Yeah.
basic ones. I read something about that the TI that basically they cannot cancel this because TI is so important for the economics of Texas because they basically have a huge factory with a lot of people working, and
Oh yeah,
if they don't use them at school, who would ever use them at all nowadays?
that's a classical thing of lobbying, monopoly, and economics, because the testing companies in the US, the one that write the tests, they for years try to switch into online calculators. So the students don't have to bring calculators with them, but just come to the exam and use online calculators. They can't because TI has such a strong lobby, and their calculators are so overpriced. Like TI calculator, even the basic one costs over $100, which is ridiculous. I mean, yeah, it's like I try to tell the students an investment in a few years because you use it all your high school and the university, so you invest $100 for at least 5, 6 years. Nevertheless, objectively, of course, it's overpriced, and but nothing can be done about that. TI is a huge monster, and you know they rule the world in this way.
The local world of American education.
Yes, absolutely. No, yeah, that's what I meant. Yes, the world of American education. Yes, that's true. That's true.
But for example, in IB school, in which I work, we also have TI 84
Yeah,
plus CE.
yeah, because yep, they're all over the world, and you can't imagine what the army of consultants they have that go around the country, make workshops, consult schools. Each district has their own TI coordinator. It's like it's a spider.
Nice. So do we move on? Do we postpone it till some next time? What do you think?
We may do some basic review and then to go into details next time. I don't
Okay,
know.
so let me like very briefly. This is the slide about what has the pure mathematics course.
I don't see the slide now.
What happened? What happened?
Your stream ended. Yeah.
Wait a sec. I'll redo it. I don't understand what. I have no idea what happened. Sorry. Let's get back to. So we have. So the mathematics course is pretty standard. I would say you have the. What's
I see the
Wait, what's-
presentation.
is it working?
Yeah, I see the presentation.
Yes.
Okay, I know that was something was weird. So we have the like basic algebra, which happens in the brackets. I put the units where it happens. Well, the coolest thing is that calculus happens beginning with unit one. You have already in unit one, you have equation of tangent line, equation of normal line. You have the funny thing, you have integral, but only in the sense of antiderivative. So it doesn't make any sense at all. You don't get to you tell the students, well, derivative, okay, that makes sense. You have direction of the graph, you can explain it somehow. And then antiderivative, well, we don't know what it is, just a mathematical exercise. Sorry, guys. In the next unit, you will find out that actually it helps you to find area, but that's going to be only 3 months later. So that's a bit weird. But generally, they have the first units are pretty standard. They have trigonometry. They have some simple geometry, like I know sine rule, cosine rule, area of a sector, something like this. They have equations, quadratic equations. They have even quadratic equations with a parameter, fancy. They have and then they have the calculus things. So they have tangent, normal, then in second unit already maximum, minimum, and area of the under the graph. They even introduced recently in P2 some section about proofs. Oh, and of course they have arithmetic and geometric sequences. And then they have proofs, which is like they learn to prove by to disprove by counterexample and to prove by using strict methods, like something like prove that x plus 1 over x is more equal than 2 for positive x. And then you need to do the correct way around. You need to first understand how to get to a complete square and then go back, something like that. And in the third,
is there a mathematical induction?
In further math, there is induction in F.
And by the way, so here it's like in the top we have P1, P2, P3, P4, and in brackets like 3, 4. It means P3, P4. Yeah.
Yeah, that's just the reference to this one.
Uh-huh.
And so the third and fourth unit focus mostly on functions and on calculus. They have that's where you get more advanced differentiation with all the chain rule, product rule, quotient rule. You get integration. You get in P4 integration by parts. You get differential equations, the simple ones, like the ones which are solved by separating the variables. You get to some 3D vectors, scalar product. You try to find, I don't know, skew lines and prove that they're skew, something like this, with vector equations. And I realized that I didn't make a slide like this for the contents of the further pure and for contents of other stuff, but I can briefly tell you that. So in further pure, it goes into complex numbers, matrices, coordinate geometry, like parabola, hyperbola, ellipse equations, up to there in FP3 they have even the ellipse equations, and they have some more technical things. They have induction in FP1. They have some sums of series. They have a lot of differential equations in FP2, where they have Taylor series. Have a lot of integrals in FP3. They learn to integrate almost everything which is integratable in standard methods, like, I don't know, 1 over any quadratic expression, something like this, factorizable or non-factorizable, or over square root of a quadratic equation, stuff like this, when you need to actually do some fancy substitutions. But the big part is the complex numbers. That's something which is pretty fancy for students, and that's further pure. And then in mechanics, well, mechanics is mechanics. I know there is nothing to outline there. It's dynamics, kinematics. You have forces, you have movement, you have some moments of forces, you have energy. Well, basically the super standard thing. And in statistics, you have the statistics 1 is a mess, but it's like very general, a little bit like Russian course for statistics in the middle school. And then statistics 2 is pretty cool because it's like probability theory. Actually, it has like binomial distribution, Poisson distribution, and then boom, it gets to all the distribution, like density, probability density function, and cumulative distribution function. So that's like pretty cool unit. And statistics 3 is hypothesis testing. You don't even need to do much. You just learn 5 formulae for hypothesis testing, which are also given to you in the formula booklet. You learn to just apply them correctly to the data. And the most interesting, of course, is decision math, because it's what the hell it is. Perfect finish for the presentation. So the decision math is basically something on the intersection of mathematics and programming, but without a calculator, or without a computer. So it's you do algorithms, you do some graph theory, but then you do algorithms on graphs. You do algorithm of finding minimum spanning tree in a graph, or finding shortest distance between 2 vertices in a graph. And then you have linear programming, which is already some mathematics. And then you have some just normal algorithms like quicksort and bubble sort, stuff like this. And then you have a huge part about like critical path analysis, which is something which people use who are project managers, about how to organize the project. That's a very weird unit, very non-mathematical in general, and at moments it's very strange, but it's definitely the easiest in terms of like how much people can be very, very bad at math and still be very successful with this one, because it's more like writing stuff. That's the overview, and then we can discuss more in details all the units later, or some single units. We can solve some paper together if you want at some point, or we can look at some selection of tasks, anything.
Yeah, so maybe a good idea is just, well, so you gave an overview, and we may look at the specific tasks and then discuss them on the next meeting.
Wait, once again, so you want
Yeah, so at home, participants can look at the tasks, try to solve them, because you said that past exams are published.
Yeah, I can offer. Wait, do you want me to make it to send to the chat some kind of a selection, or or just some papers?
Homework.
Oh, homework. Yeah, that will like. But yeah, okay. But we can. I mean, it could be a mix of tasks from different units, or it could be just a full unit of something for you to discuss, for people to look at. I don't know. What do you think? Or a couple?
Maybe interesting tasks from different units.
So I can make a selection of more of tasks which I like. My own selection of tasks from several units, something like that.
Yeah, you know your playlist.
Okay. Fine. I think that I won't make it a mix of everything. I'll try. For example, at the beginning of just the first pure models, for maybe, or maybe adding FP1 to it. I will think, but maybe we can do at a different moment. We can discuss some mechanics or statistics or together. Like the poor British students who have to take mechanics statistics exam now.
Okay.
Is there any?
All right.
Okay. Can I ask a question? Like,
Yeah, sure.
is there any math in mechanics that's not covered in general math, or is it just physics topics? The math
No,
is the
that's
same
the
math.
point. They are very careful. The application units, they're called application because they are supposed to teach students to apply their knowledge of math into more realistic situations. So no, the level of math in mechanics is very simple. Actually, in mechanics 3, they happen to have some, because they have oscillations there, so they get to some pretty fancy differential equations. But I'm pretty sure nobody ever studies mechanics 3 in normal math. So it is further math, and those who do further math, they're supposed to know these equations already. So it's all pretty balanced in this sense.
Oh, okay. Okay.
Yeah, and mechanics 3 is not studied in ordinary math, because in ordinary math, like first 4 pure maths are obligatory, yeah?
Yes,
And then
and you are not allowed to take M3. Yes, you may only at maximum take M1 and M2 there.
Uh-huh. Okay, thank you for your talk.
Oh, you're welcome. Nice meeting everyone. Maybe see you another time.
Yeah, I hope so next time, or like in 2 weeks, as you want, Sergey.
Yeah, okay. I'll first post some tasks for you in the
Yeah.
in the All right. Thank you, everyone.
Okay, thank you for the talk. See you next time.
See you.
Thank you.
Bye.
Thank you for this meeting.